We're good to go, Mr. Chair.
Okay, I can get that off my screen would be helpful. There we go. I guess Phil, I'd like to call today's special Lake Auburn Watershed Protection Commission meeting to order. And I'll turn it over to Erica to introduce the presentation we're having today.
Sure. Thank you everyone for joining. I know this is not our regular bi-monthly meeting, but I'm glad I could get a majority of the commissioners to attend today. We have on Zoom here Heather Doolittle. She will be giving the presentation today. She's staff engineer with Ty and Bond, which is the consultant that we hired to do this study on Blanchard Pond, which is in the watershed just off of Route 4. And the title of the study that was put together is Blanchard Pond Watershed Study, Evaluation of Blanchard Pond and Downstream System and Associated Subwatersheds for Removal of Phosphorus. And I think we also will have Dan Bison joining at some point here. He is also with Ty and Bond. He's a vice president and engineer with the firm, and he works with Heather. And Heather is based out of the Portland office still, right? But probably remote. Okay. And Heather gave this presentation at the Maine Water Utilities Association trade show earlier this year in February. And it was a great presentation, so I'm glad she's able to do it for the commission as well. So I'll hand it over to Heather.
Okay, thank you, Erica. And thank you everyone for taking the time here today to listen to the presentation that I'm about to give and your engagement here. So let's see if I can just share the screen. All right, is everyone able to see the screen share here? Okay, great. Just like to give a little bit more background on myself. I first got involved in Lake Auburn and the Lake Auburn watershed back in 2013 as part of my graduate research up at the University of Maine. From there, I've been involved on and off throughout. I had played a little bit of a role with the alum treatment that happened back in 2018 in Lake Auburn. And then most recently with this study here, looking at the Blanchard Pond system within the Lake Auburn watershed. Just to go through a little bit of agenda about today, I'm going to start off with project background, previous work that's been done in the Lake Auburn watershed, then dive into the Blanchard Pond system itself as a sub-watershed within the greater Lake Auburn watershed. I'm going to talk about some of the analysis that we did of sampling that's been done previously and as a part of this study in this system, and then take a step back and compare it to previous studies that have been done in the entire watershed to get an idea of how this Blanchard Pond system fits into the greater phosphorus and nutrient budget for Lake Auburn. I'm going to present a little bit on the remediation strategies that are available to help limit nutrient loading to lakes specifically. And then finally wrap up with the summary and recommendations of the study that we did last year. So starting off with a little bit of the project background. This here is Blanchard Pond. You can notice this beautiful green color that is algae growth. This photo was taken mid to late July 2018 from an aerial drone. This area here in the foreground, this mowed area, is part of the drainage area that goes directly to Blanchard Pond. We'll talk about that a little bit later. You can see Route 4 passing through here, and then Lake Auburn itself back here. So Lake Auburn is a unique case study in many ways because it is one of only a handful of unfiltered drinking water supplies in the country. It has this filtration waiver because of its long history of strong watershed management and also very clear, clean water, really low turbidity, low algae growth. And that's a result of really low total phosphorus concentrations in the water column. Something else that's significant about Lake Auburn is that it has a relatively long hydraulic residence time. So this is the amount of time that it takes, say, a water molecule when it enters the lake. This is how long it takes that water molecule on average to then leave the lake. So that's 3 to 5 years. So anything coming into the lake, it takes 3 to 5 years for that to then flush out of the system and be removed from the lake. Over the last 10 years, there's been this trend of increasing total phosphorus in the water column in Lake Auburn. If you look at the historical record, which I believe begins in the late 70s or early 80s, and look up through about 2010, the average total phosphorus concentration is around 8 parts per billion. Nowadays, that total phosphorus concentration is around 12 to 14. Which might seem like not that big of a change, but in terms of the amount of algae that phosphorus concentration can support is significant. And it's especially significant because of this filtration waiver that the EPA has granted the cities of Lewiston and Auburn for using this as their water supply. Phosphorus is important in this case. It's the important nutrient because it is the limiting nutrient in Lake Auburn. That means that the amount of algae growth that occurs is directly proportional to the concentration of phosphorus in the water. So there can be other nutrients, there can be sunlight and such that also control that growth, but the phosphorus is the limiting nutrient. So as that phosphorus increases, that is directly correlated to increasing algae in the lake. Lake Auburn is a little unique because it has 2 significant sources of phosphorus. One comes from within the lake itself, from the sediments in the lake. This is through a process called internal loading that largely is what drove some of the significant water quality events that occurred in 2012 specifically. But it's also susceptible to the external load of phosphorus. And that's really everything that comes in through the watershed, through tributaries, through runoff and such. And this study is really focusing on the external load of phosphorus as a way to limit the amount of phosphorus that's coming into the lake. So when we talk about phosphorus, specifically how it relates to lake and reservoir systems, it's important to think about phosphorus as a load of phosphorus, which is typically in units of pounds per year, or can be normalized for land area into pounds per acre per year. You don't measure the load, you calculate the load through sampling for concentration and stream flow. So knowing what the flow coming in and the concentration of that flow coming in to your target water body is how we calculate this load. And that allows us to look at the relative impacts of certain inputs into the lake and how they relate to one another. This cartoon here just kind of shows to illustrate this. If you have a high concentration source that's really just a trickle into the lake, even though that high concentration can throw up a red flag, that's low flow actually makes it so it's contributing a lower amount of the total phosphorus budget. This cartoon over here shows the opposite, where you have a really low concentration at a higher flow, and that's actually the system that's adding more of that total load to the target water body. When looking at prioritization of watershed remediation projects, looking at the total load can be important because it can help figure out where you're going to get the most bang for your buck when looking at some of these remediation efforts. So in this figure here, what we're just showing is for a % reduction for the low concentration versus high flow. If you get a 20% reduction in that low concentration input, you're seeing almost a 1 pound per year decrease in loading. Where this orange line down here, this is your high concentration low flow. To get that same 1 pound per year loading decrease, you have to go closer to 40% reduction in total phosphorus coming to the system. So this doesn't mean that all focus should be put on low concentration, high flow systems or vice versa. It just means that it's important to look at the whole picture and weight how different systems might be impacting the water body that's being targeted and where the greatest improvement is going to be able to be realized. So the Lake Auburn watershed itself, this red line here outlines the Lake Auburn watershed, with Lake Auburn here located in the southern part of the watershed. It spans across 5 towns, which can make watershed management efforts a little bit more challenging. It has an area of 14.7 square miles. The Blanchard pond system is located right here, just to the northeastern side of Lake Auburn. Blanchard Pond is barely visible on this figure, and then the stream system that connects it to the lake running through here under Route 4. For reference, we have the treatment plant down here. There have been a lot of previous studies done in both the lake and the watershed. The most recent watershed management plan was done in 2010, followed up in 2013 by the Lake Auburn diagnostic study that really focused on lake water quality, algae growth, and the internal loading within the lake. There have also been ongoing research projects led by research teams both at Bates College and the University of Maine over at least the last 10 years. And then there is frequent and routine water quality sampling that's done in the watershed. So there's monthly watershed sampling, that's stream flow measurements and water quality sampling. And then in the lake, bi-weekly sampling at a number of sites throughout the lake. Blanchard Pond itself and how it fits into this system was largely overlooked in previous studies. It had previously been attributed to this Route 4 sub-watershed over here, missing the fact that it is in fact directly connected hydraulically to Lake Auburn through the stream system. And it really had never been sampled until 2018, when a grab sample was taken after noticing during routine watershed observations, noticing that there was a lot of algae growth there. A grab sample was taken and it showed really high total phosphorus concentrations relative to elsewhere in the system, almost 400 parts per billion. If you remember, the concentration of Lake Auburn is closer to 10 parts per billion. So that really is what started this process going. There's this really high concentration of phosphorus in this previously understudied part of the watershed. What is the impact that this system is having on the lake, and what opportunities might there be to help prevent some of that phosphorus from getting into Lake Auburn, with this idea of reversing this trend of increasing phosphorus concentrations in the lake. So that brings us to this study, where in this part, what I'm really going to do is talk about Blanchard Pond, the physical characteristics of the pond, the stream system leading to the lake, some of the things that we observed in this small watershed. And so let's dive in there. So again, this figure, we've got this map, Blanchard Pond located right here with this stream system. We started out with a physical investigation of the pond and stream. How deep is the pond? How big is it? Delineation of the Blanchard Pond watershed. When we say that, we're talking about this whole drainage area to the stream and the various subbasins within it. And just to get a better idea of what are we dealing with, what opportunities might be available to try and reduce this phosphorus load coming from the system. So here we're talking about Blanchard Pond in general, and this sort of just summarizes what drains into Blanchard Pond. So the land area that drains into Blanchard Pond, all of that former pasture land that's now mowed, is 1.2 acres. So you can see it's, 2,000th of a square mile relative to, the 15 square mile watershed of Lake Auburn. It has a perimeter of 610 feet. Surface area of 0.3 acres. It's a little over 6 feet deep. And what I want to point out here is this really short hydraulic residence time of about a third of a year. Remember, Lake Auburn has a residence time of 3 to 5 years. This is only a fraction of a year, really only a few months. And this is important because everything that comes into this lake is being removed from this, or this pond, excuse me, is being removed from this pond very quickly. Going into a little bit more detail on the different subbasins. So here again, we have Blanchard Pond right here, and then Route 4 coming up north to south here, and Lake Auburn down in the bottom left. There are 3 existing sample sites established within this system. So Blanchard Pond, which is sample ID B1. This is right at the culvert leaving Blanchard Pond, so where water spills out, and that's really representative of the water quality in the pond. The stream system then passes here, through the woods, crosses underneath Route 4, and pops out at sample site R2, again at the culvert coming out from the other side of Route 4. This has a drainage area of about 19 acres. You can see the outline of that subbasin right here in green. The water then flows down continuously through the stream, crosses underneath Lakeshore Drive, and sample site 25 is essentially the water that's going directly into Lake Auburn. And you can see that this red area, that is the delineation of the drainage area to sample site 25, and that's about 70 acres. So still relative to that 15 square miles of the total watershed, still a very small system. In the beginning of this project, to really get a better idea of what's going on in this system, we went out and we walked the stream, took notes, observations, and photos of various things throughout the stream that could potentially be leading to increased phosphorus loading from the system and potential opportunities for remediation and decreasing that phosphorus load. Specific things that we're looking for would be significant signs of erosion. Erosion can be problematic for phosphorus because one, there can be a lot of phosphorus bound up in soils, existingly bound to the soils that can then be mobilized through erosion. But also phosphorus is sticky and it likes to stick to soil particles. So anytime you have a lot of solids being transported through the water, that can stick to existing phosphorus in the system and be a mode of transport for the phosphorus. So erosion is a big thing to consider when looking at this. Other things we were looking for is if there were really obvious signs of people dumping yard waste down near the stream, or animal waste, or any sort of discharge site that could be potentially problematic to water quality in Lake Auburn. On the next few slides, I'm just going to show some of the photos that were taken from that site walk and point out some of the noticeable things that we had. I do want to point out that there was one part of the stream that was unable to be accessed. Growth was just too thick in that area to make it through, but the rest of the stream was able to be observed. So this is Blanchard Pond. This is a north-facing view. This is the drainage area to Blanchard Pond, this field right here. I want to point out that this is mostly grass right here. There isn't a lot of growth that would serve as a sort of buffer to prevent any runoff from this part of the system coming into the lake or the pond, excuse me. Turning about face, this is looking downstream, the culvert connecting Blanchard Pond going under Blanchard Road, connecting it to this downstream wetland, runs right about through here. And I do want to point out that these photos were taken in late May. So this is not algae growth that you're seeing. This is actually just all of the pollen that found itself on the water surface there. Moving further down the stream, this right here, now we're looking at Route 4, and you can see this starts to turn into a more flooded wetland again. After going from the upstream wetland, it goes into a stream channel, and now it's back to a flooded wetland, a lot of standing water. The reason for this is because there is an impoundment right here, essentially a dam that is preventing water from the stream from flowing naturally through the system. This is a potential concern from a water quality standpoint, because if this impoundment were to breach or overflow, it could potentially send a large volume of phosphorus-rich, organic-rich water downstream in a single event. That can be very significant from a water quality standpoint, as opposed to having something introduced slowly over a period of time. Something else that I want to point out is there's a little bit of erosion here on the western side of Route 4, potentially another transport mechanism for phosphorus in this watershed. Now what we're looking at is the opposite side of Route 4. This is the culvert coming out. This photo is facing downstream. This photo facing the opposite direction. It's facing upstream. The culvert is right around here. You can't really see it from the growth and the angle of this photo. But what I want to point out here is this sort of riprap, some sort of effort at stream bank stabilization that appears to have been done in the past. To help prevent erosion of the land right here. You can see some noticeable erosion in this photo on the edges here. And something else that I want to point out is the shape of the stream as it comes out of the culvert, this sort of bell shape right here. So this is indicative of a culvert that is essentially undersized. So what happens is as flow is coming through the system, you've got a higher flow rate. That culvert starts running deep, high velocity. And then as it comes out, essentially it blows out of this culvert. It gets this dissipation of energy and can cause a lot of erosion right downstream. Moving just 20 feet further downstream from that culvert, we noticed something very interesting, a very significant shift in the stream bed sediments. So upstream, it was this mostly silty, sandy, a little rusty color, some places very coarse sand, and there was a very dramatic shift to this dense blue clay. Very clearly Presumpscot formation. We're going to talk about that a little bit more in the next few slides. But first, just moving down the river a little bit more. So now this is moving closer between Lakeshore Drive and Route 4 now in the stream system. Some more signs of erosion here underneath the bank. And then this orange and red area that's iron deposits. So we're having some sort of iron oxidation in this system that can be from groundwater inputs, but also likely indicative of wet dry, which really oxidizes that iron and gives you that red color. And then here's where the stream finally enters Lake Auburn. Lake Auburn is located here on the bottom right of the photo, and you can see this erosion of this sandy beach coming into the lake. So jumping back into Presumpscot formation, what Presumpscot formation is, for those of you that might not be familiar, is it's a marine clay that was deposited thousands of years ago after glaciation, when sea level was actually right around the level of Lake Auburn. So it's really prevalent at that elevation throughout the state, specifically in central Maine. And it's important for a number of reasons. One is it's very unstable, so it's prone to landslides and erosion. And the other reason that it's notable is because it actually has phosphorus containing minerals within it. So it can be a source of phosphorus itself. So it's kind of two ways to transport phosphorus. One, the actual sediment or soil itself, the clay itself, has phosphorus in it. Number two, it's prone to erosion, another transport mechanism for phosphorus because that phosphorus can stick to it. There was a study done a number of years ago now at the University of Maine that looked at the presence of Presumpscot formation in watersheds with high productivity rates, so a lot of algae growth, and watersheds that had lakes that had very low productivity, low algae growth, like Lake Auburn historically does, and found that the presence of Presumpscot formation statistically correlated with the amount of algae growth in the lakes. So now moving on to phosphorus loading, we're going to jump into some of the specific sampling that was done as part of this study. So something about this system is because it was so recently identified, there isn't a very long record of water quality sampling and stream flow sampling in this specific system. Sampling is done routinely by Auburn Water District, Lewiston Water Division, starting in 2018 in this system. So that would be at the 3 sites, leaving Blanchard Pond, crossing Route 4, and coming into Lake Auburn itself. So 2018, there was some initial sampling. The routine sampling didn't really start until 2019. So we're really only working with 2 years of consistent sampling data for this. And then there's limited historical data. Going right into Lake Auburn, that record begins in 2016. But what I want to say about this is, with the limited amount of record that we have at this point, only so much can be said about this system, and it's really important to continue to study it so this record, it can be longer and we can have a better idea of what the baseline conditions are in this system moving forward. So moving into some of the sampling results, these tables and the figure here is showing phosphorus concentration. So this is total phosphorus concentration in the water samples. This figure is showing total phosphorus concentration over time. So starting in 2016 and moving through 2020. The blue points are B1, so that's coming out of Blanchard Pond. The orange squares, site R2, that's crossing under Route 4. And then green is site 25, so that's what's coming directly into Lake Auburn. And this figure here really shows the high phosphorus concentrations that have been measured in Blanchard Pond. And then you can see that there's much lower phosphorus concentrations measured downstream in the system. And then this table here just goes to summarize those data points, maximum, minimum, average, and median values.
Heather, Dan has raised his hand.
Yeah, just
Yep, sorry.
so that chart that you just had up, this one here, it really does pinpoint the pond itself as a contributor of the phosphorus, because for a while, you know, I'm quite familiar with the Wallingford equipment, you know, this oil-based petroleum products. It's been there for a long time, and I thought maybe there was something also there, but then you measure it coming out of Route 4 and it concentration. So the buffer there is treating that phosphorus, total phosphorus, and then as it comes out, even more of a buffer comes out to Lake Auburn. So have we looked at any other issues in that 1 mile of watershed for Blanchard Pond, or is it all really coming from that little pond?
Yeah, so I mean, that's a really good question, Dan, because remember, right now we're still looking at just concentration. So we're going to move a little bit further into looking at what the stream flow is, and then also what the total loading is from the system. And I think that's where the story starts becoming really interesting.
Okay.
So diving into stream flow, now we can see that even though the phosphorus concentrations are so high at Blanchard Pond, the actual amount of water that's coming out of Blanchard Pond and into the stream system is much lower than what's happening at site 25 specifically, but also what's going on at R2, which is crossing under Route 4. So even though we see those high phosphorus concentrations that initially threw up all these red flags, when we look at the stream flow and then we bring that all together, what we're actually seeing is the amount of, so right here what we're showing is the phosphorus load. So we've taken that concentration and the stream flow measurements. Remember that these are all grab samples. So these are snapshots in time. But by putting it all together, what we can see now is that the loading, so the pounds per year that's coming into Lake Auburn, so that's site 25 crushing underneath Lakeshore Drive, is considerably higher at some points, especially during high rain events like you see up here, especially in the late summer and early fall, than what's coming out of Blanchard Pond, which are these blue points right here. Now, since this is, these are grab samples, they're snapshots in time, we're probably missing some peaks, we're missing some really low points, we're missing some middle points, but you can see in general, the trend of, even though there's this really high concentration at Blanchard Pond, the total mass of phosphorus that's being released, the pounds per year, is much lower than what's actually coming into Lake Auburn down at that site 25 at Lakeshore Drive. Does that answer your question a little bit, Dan?
Yes, thank you.
Now here on this table, what I'm showing is it's the same information, the same data that was shown in the previous figure, except now we're summarizing it. We've got average loading rate, median loading rate, and maximum loading rate. And what we've done is we're showing both pounds per year, but we've also normalized against the drainage area, so pounds per acre per year. So this gives us an idea about how land use is impacting that phosphorus export from each one of these different subbasins within this Blanchard Pond and stream watershed within the Lake Auburn watershed. So the loading, you can see, gets higher in many cases going from Blanchard, the total loading going from Blanchard Pond to Site 25, largely a result of the increased stream flow at that location, the increased size and drainage area that we have going down through the system. But also what we see is the pounds per acre per year is consistently elevated at Blanchard Pond. So what this says is that the land use at Blanchard Pond, there's a lot of opportunity there to reduce the phosphorus loading from the system, right? Because it's much higher, this per acreage loading that's coming, right? So there's opportunity there for remediation. But most importantly, we can talk about Blanchard Pond all day, but the only time it really becomes important is how does that relate to the rest of the watershed and the goal of limiting the phosphorus load to Lake Auburn. So in this table, what we're showing is these are the everything down in this table in blue is showing the estimated loading, the calculated loading from the 2010 watershed study. And up here highlighted in orange is what we're seeing from the Blanchard Pond system. So the Blanchard Pond system was previously associated with this Route 4 subwatershed within the Lake Auburn watershed. So we've taken what we've calculated from this Blanchard Pond study out of Route 4. So now it can stand on its own, we're not double counting it. And we have to be a little bit careful with this because two different methods were used to come up with these values, but I think it still shows a good picture of what's going on in the system. So the numbers that I want to point out here is the percent of the total load per year. So this is the total annual load that's coming out of this watershed, right? So this is what really matters to what's coming into Lake Auburn. That's how we frame this watershed budget. This nutrient budget is 1.9%. So 1.9% of the phosphorus exported from this watershed is coming from the Blanchard Pond stream. But, so not very much, right? But if we normalize that for the size of the watershed, again, you can see that this is much higher than the rest of the values here at 0.49 pounds per acre per year. That's based on the average loading coming out of this watershed. So this tells us that there's a lot of opportunity for remediation projects in this small area. Well, this tells us that Blanchard Pond most likely is not the big driver of increasing phosphorus concentrations in Lake Auburn. And then this figure just illustrates that a little bit better. I think in figure form, so phosphorus loading pounds per acre per year. So we're normalized for drainage area and the various subbasins within the Lake Auburn watershed. This orange line here, this is the average load relative to the average loads that are shown here. Median for such a small system is probably a more accurate or more realistic measure to use. And that's because the system is such a flashy system that you can get a lot of outlier points just because of the size of it. It's going to change a lot. And so if we look at the median, but still looking at this land use within the watershed, there's a lot of opportunity here to reduce the phosphorus load relative to, say, some of these other subbasins that have much lower load per acre. And then if we look at it in terms of the total phosphorus that's being mobilized within this watershed, it drops out to one of the least contributing sub-watersheds within the Lake Auburn watershed. So moving on from there, what I'd like to do is talk about some available strategies, both in the pond and the stream that can be used to limit the amount of phosphorus that's being mobilized. So starting with the pond, there's a number of available strategies. First and foremost, probably the most common would be riparian buffer. So before I showed in the image of Blanchard Pond, it's all grass coming down straight into the pond. What a riparian buffer would do is incorporate various size plantings in a zone around the pond that would basically serve to slow down and dampen the amount of runoff that's coming right through those fields into the pond. So by slowing it down, you're giving more opportunity for it to seep into the ground, kind of as a natural filter. You're also giving more opportunity for plants to take it up, and you're kind of reducing this, the amount of erosion that can happen through this runoff, the amount of things that can be mobilized to that really fast flow across the land. This figure here just kind of illustrates what a poorly buffered system would look like, with just grass or farmland going into directly into the lake. With a buffered system, we'll have some sort of plantings in a zone around the pond to slow down that water coming in. Other strategies that you see in practice are dredging. Dredging is not the most ideal solution from a phosphorus remediation standpoint. It can be good if you're dealing with more heavy metals or some other contaminant, or if you're dealing with invasive aquatic species, such as milfoil or something. But it can be very damaging ecologically. It has poor results when used from a nutrient water quality perspective. It can be challenging to permit, and the disposal of the dredge material can be another challenge.
Heather, Dan has a question also.
Oh, yeah.
Just curious, has anyone contacted Mary Jane Dillingham? She used to own the property. She raised horses there. Maybe she has a history of, like, did she have, like, for instance, Pat Bates coming over, spreading manure for the fields, for their crops? I mean, has there been a change of use? Or is it still the same use that it's been for at least the last 20 years that I've seen it? And maybe the other question, it's a two-part question. Was this design, this pond, looks about the size of my pond, to treat, was it part of a phosphorus control plan? Was this pond designed to do a certain thing? If so, if it's was man-made built, is it still doing what it's supposed to be doing? So I see we're trying to move towards fixing the problem, but maybe it's a design flaw, or maybe the fertilization of these fields are continuing to happen.
So I have not spoken with Mary Jane about this property, but I have contacted the current owners, and they were open to us studying the pond, talking to them about possible remediation strategies to uptake phosphorus. But I do know, and Heather knows this as well, she went out and did the field work. They do have livestock. They are tilling some of the soil. They are mowing it. They do have a couple greenhouses. So there's a lot of activity still going on at that property.
Okay, sorry to interrupt you. You know, I mean, our water quality manager has owned this property for like 20 years, I'm guessing. So our former water quality manager. And I know Dan Beeson, I know Heather, I know you guys all knew MJ. So I think we should contact her too as part of this study.
I do know that that pond did not start to be studied until after she left. But we can certainly talk to her and try to get some more background information.
Yeah, absolutely. And for my conversations with Mary Jane on this, you know, I know that when she first came to the property, there was piles of former manure right next to the pond. I know that she tried to implement a low nutrient fertilizing option in the fields. only know from observation what is currently being done by the current property owners. So I don't know what their fertilization practices are. Another alternative strategy for remediating the pond is something like was done in Lake Auburn a few years back, the alum addition. In a system this size, the alum addition looks very different. It would probably be the first year or couple years, a number of different applications over the course of the year, and then an annual application from there on out. And that's just because of the size of the system. Especially without managing the external load of phosphorus coming in, that really becomes long-term management alum every season after the first kind of initial period of dosing. And then aeration. Again, aeration can be good if there are issues, aesthetic issues such as slime forming or on top. Or smell, or if there's a significant internal load of phosphorus. But here in Blanchard Pond, it's still largely, we believe, the external load coming in from that field.
So Heather, there's a series of strategies there, obviously, but a couple of those strategies are really aimed more at internal loading than external loading, right?
Mm-hmm.
Riparian buff is external, dredging's internal. Dredging's a one-time, you do dredging once, and if it's an external load, that's really not going to help anything.
Mm-hmm.
Alum the same way. So I'm guessing really some of those aren't practical, partly because back to Dan's question about why the phosphorus there in the first place and where it actually exists or where it's being contributed to, right? So I would assume some of those we would eventually take off this chart because they don't really suit the, right?
That's exactly right, Dale. And when we get into the recommended strategies, we'll hit that note a little bit. But that's why the riparian buffer really is a standout option here, because it's helping prevent that phosphorus load from getting to the lake in a very natural way, without land use changes can be challenging to implement because they require so much buy-in from the property owner, obviously. So something like a riparian buffer, if the landowner is amenable to that, it could be a good solution.
Dan, you've got your hand up?
Yeah, thank you. There's a perfect opportunity for us to contact the Androscoggin Valley Soil Conservation District because they work with farmers. They may be able to remediate a lot of this issue on their tab too. So that's also one other recommendation that I would love to see happen is we get a hold of them because there may be all kinds of options available and money's available to fix that as well.
They do offer matching grants, and specifically for this type of project, it's usually on a larger scale, but this falls within the guidelines of grant funds that they offer to work with landowners to change some practices to get better results in the watershed. So that's definitely an opportunity.
Great points. Thank you. In terms of the stream system, a little bit different of approach. These ones, available remediation strategies are really targeted more at preventing erosion. So preventing that transport mechanism for phosphorus in the system. Looking at removal of the residential impoundment, obviously challenging because of the buy-in that would be needed from the property owner there. But if it becomes an available solution, that could be one to pursue. In terms of something that might be a little bit more attainable, would be looking at stream stabilization and erosion control around that Route 4 area. So stabilization of this bank here, trying to prevent some of the erosion through plantings or stabilizing materials. And then obviously upsizing the culvert under Route 4, challenging because of the coordination needs to happen with DOT on that. But if there are plans to resurface or do work in that section of Route 4, that could be a good opportunity to initiate that dialogue with DOT. And then also on here, we have in-place treatment technologies. These are essentially like filters that would go inside of a manhole. The ideal placement for this would probably be in Lakeshore Drive. And what that would be the stream would flow through this system, and it would pull out any phosphorus and sediment before it went into the lake. These can be challenging to operate simply because they require a significant amount of maintenance. And if they are not properly maintained, they can fail, which could be a catastrophic event for Lake Auburn by taking all of this material that's been pulled from the stream to prevent it from getting to Lake Auburn could all be released to the lake at a single point in time. So those are kind of what we're working with for available strategies. And now I'm going to dive into kind of just the summary of this report and some of the recommendations going further. So in summary, based on how the loading from Blanchard Pond came out in this report relative to elsewhere in the watershed, I think it's safe to say that Blanchard Pond is not a significant driver of the rising phosphorus concentrations in Lake Auburn. That being said, because of that high pounds per acre per year normalized loading rate coming out of this system, it looks like there's a lot of opportunity to manage the nutrient load within this system. And then, of course, since, you know, continuing to observe, identify, and manage other potential opportunities throughout the watershed to decrease that load. So the recommended remediation alternatives from this study are, one, to install the riparian buffer around Blanchard Pond to try and decrease the amount of phosphorus that's making it to the pond in the first place, decrease that external load to Blanchard Pond. And then to look at the Route 4 erosion control and stream bank erosion and projects that begin in there to try and prevent that downstream transport of phosphorus. In terms of next steps and things that should continue to be done is, of course, continuing to sample this system and the existing sample sites throughout the watershed. The longer record available of data in this system, the more we're going to know, and the better we're going to be able to identify things that might be changes in land use, changes that might be occurring throughout the watershed. But also helps us better establish what that baseline condition is within the watershed. And then if pursuing the Route 4 erosion control projects, looking at the actual soil chemistry and characteristics and what's being eroded downstream to make sure that that project can be really targeted to address the areas that could be most impactful. And with that, thank you again for listening, everyone. And if there are any other questions, I'm happy to discuss.
Thank you, Heather. I did this in our last presentation too. I should have introduced who we have on here before you got started. So I just want to let you know who we have on screen here. Commissioners Dan Bilodeau, Steve French, Dale Dowdy, Alan Holbrook, Amy Landry, and Evan Sear. Dan is a Auburn Water District trustee and a representative of the trustees to the commission. Steve French represents Hebron, Minot, and Buckfield. Dale is with the city of Lewiston in a probably a different role than last time we talked. He's in city administration now. Alan is our representative from the town of Turner. Amy works at the Androscoggin Valley Council of Governments, and Evan is a representative from the city of Auburn. And you know Sid, you know Kevin. So yeah, I'd like to open it up to commissioners or staff. Any questions for Heather? We also have Dan Bison on Zoom from Ty and Bond as well.
Heather, I think you mentioned earlier, and Dan had asked about the Soil and Water Conservation Commission, which I think is a great idea. Have you also made contact with DOT to see where they are with this culvert? I think I know, but have you talked to them to see where that is?
That's a good question. I not, Dan, do you wanna, can you answer that?
We've not contacted DOT. I don't know the status of that, Dale. If you said you did know what the status of that is, that would be helpful. You're on mute.
I suspect I know. I'm not to the point where I'd want to commit it in a meeting, but
Yeah, I mean, in essence, our report is here to provide recommendations in terms of step forward. There's a few ways to go here, it seems like. The takeaway I had from the work that was done, I think on the onset of this project, I guess the thinking was that, there's probably a smoking gun there in terms of responsibility for what happened to the lake overall. And I think through this analysis and both from the site, physical site and desktop modeling and calculations, that doesn't appear to be the case. But it does put it into a lot of context, how to go about looking at your watershed over time and making decisions on how to proceed to kind of correct those issues. And a lot of other clients we have in working with their watersheds, very rarely is there one smoking gun. It's usually a combination of a lot of different things over time. And that's hence the need for watershed management in both a policy and an implementation scale. Folks are working on their watersheds all the time to try to address this. As development happens around any area, that's the challenges we have as we grow as a community, as a society, to track those issues, because it's all the little ones that add up over time that create a much bigger challenge for us. That's pretty consistent with what we've seen in other places.
Dan, you have your hand raised?
Yes, thanks. Heather, great presentation. If you can make the slides available to the Auburn Water District and also the LawPEC commissioners that are not present, that would be really good. But I also want to add, and Dan Beeson has really hit it on the head. This is an eye-opener to all remediation, phosphorus control plan type ponds, including mine in my own backyard, the health of those ponds. Just a site visit like we do for our, the land trust looks at our easements to see how changes of use could be happening. We should be looking at all these. There must be at least a dozen or two of these types of ponds that could be tested. And it wouldn't be too difficult to at least get some baseline testing going. And then to be looking at, because like you said, these little things will add up to the bigger thing at the end. And, we put in Spring Road as a phosphorus allocation area, but there are at least 7 ponds I know of feeding culverts that cross the Spring Road. So, what are those ponds doing? And this is a big eye opener for a single pond for us. This is good.
Yeah,
And
I
thank you,
agree.
thank you, Dan.
Oh, go ahead.
No, go please, Erica.
I was going to say it is interesting once you have these tributaries to the lake, right? And once you start walking back upstream, where are they leading and what is in those inputs? That's a good point. And if we can work with, our landowners in the watershed like we were able to with this one, I think it would be a good idea to see what are those ponds containing, what's the water quality, where are they located? So that's definitely something we can look into going forward.
Mm-hmm. And even using a project like this, or what was done at Blanchard, what is done at Blanchard Pond, what will be done at Blanchard Pond from a public education, community outreach type standpoint of, this is what we can do. This is the impact that it has. This is why it's important.
So I just have, thank you for the presentation. It was really helpful. So I know just as a commission, and since I've been on it, we've looked at Townsend Brook and, we've got different pieces of data about different points, I guess. I'm thinking about the chart that you showed that had all these other things that had much higher concentrations. And I'm thinking as a commissioner, for us to prioritize, maybe some of the solutions with this, we could get grants and that would help to pay for that. but what is going to be like the most bang for our buck, I guess? Like, where should we be focusing our efforts? So if Blanchard Pond isn't, but we could do something that's not really costly, or we could get a grant, then yes, maybe we should do that. But for us as commissioners to be able to prioritize where we should be looking to make the most impact with our dollars, I guess, is kind of what I'm thinking when I'm looking at that chart. And that's not the highest. Maybe it's the easiest to solve. So we do that because it can prevent future impacts. But I think it would just be helpful for me to kind of understand some other things we might be able to do in other places to help.
Yeah, Amy, I can certainly add that to our next meeting agenda, because we do have several large scale studies that have been done, and we've got a lot of information and a lot of recommendations on different parts of the watershed. And I do think that's important to be clear on what is the most bang for your buck, right? And also understanding, some of those studies were done in 2010, 2013. So they're getting older now. And we just had that presentation from Lars Gunderson, a recent Bates graduate, who showed some newer information, looking into Mud Pond. And I can present that to you guys. I've worked on compiling that. It's a lot, but that's what we want to know, right? Is what would be the most impactful. And I can say that this year we want to do work on Spring Road, which is higher up on that list than Blanchard Pond. And hopefully we can improve some of the drainage there and contain some of that erosion and sediment movement that we've been seeing. So that might be higher up on the list, but I agree with you too that the Blanchard Pond, might be one of the easier ones. But as Heather said, the potential for it to be a bigger problem is there based on the land use. So it might be a smaller impact right now, but the prevention might be priceless, one of those things. But yeah, I'm happy to talk more about the prioritization of hot spots, which there is no smoking gun, but hotter spots in the watershed at our next meeting.
Yeah, I think it would just be helpful to kind of see all of it in one. It's great to have these presentations, but then we go away and it's like, yeah, I remember parts of it, but to kind of look at everything together and say, okay, these are the recommendations here. This is what it could do. That kind of look at it would be helpful.
Sure.
I might offer another thoughts to the board here. In a lot of work we're doing in this kind of area, we're in like the mode where behavioral change has to happen to understand the world we're living in. In the environment with climate change, with increased, more intense rainstorms, things are changing. And as engineers and scientists, we're watching and observing this. We see this all the time and every day. I've been doing this for quite a while, and every day I go to work, we have different challenges popping up that we're now aware of. I think the value of trying to get the public education piece out there to prevent problems that are going to happen in the future that haven't happened yet because people haven't made the changes. But if they're cognizant of that and they don't create that problem, then it's much easier to solve it that way. It's kind of an iterative process, and it's in that PR piece of education. Like you said, you look at something and you go away and you come back to it. Well, you can't really ever go away. It has to always be there in the watershed. It's something that has to be protected every day. And it's never easy to go back and undo stuff. I look at in Maine, some of the best things I've seen for behavioral modification is like in the stormwater realm, where they did little rubber duckies and they correlated that into the media, and pretty much people got it really quickly. They understood it, they can see it, and then now they understand stormwater and stormwater contributions to pollution going forward. There are a lot of folks doing this. Everybody that has a watershed is doing good work out there. There's lots of things, and Eric, I know you know a lot of this and collaborate with all the other folks, and you board probably all know too, but what we see is that process to which education happens on a continual basis, increases the chance of success in decreasing some scenarios that happened to you back in 2012 in those conditions on this specific water body. But Lake Auburn is not any different than any other right now. Everything is in flux and changing. And, we need to be very cognizant of that going forward in terms of any solution or any investment to change, to correct things of the past. Changing things in the future is a lot less expensive in that fashion.
Thank you, Dan. Dan, did you have your hand up again? Okay. While we still have everybody here, any other questions or comments from commissioners or staff?
Must have been a good presentation, not too many questions, right?
Okay. Well, thank you so much, Heather. I appreciate you taking the time to do this for our board. I think it's really important and helps explain further, the results of that study and the recommendations. And I'll be talking with you and Dan after this about it more. But I think it was really helpful to have as many people on here as we could to hear the work that you guys did. So I appreciate that. Thank you.
Yeah.
And I have been recording this presentation. I'll share it with other commissioners who could not join, and we'll have it on our commission website as well for others to view.
All right. Well, thank you, Erica, and thank you everyone again for inviting me to speak today.
Thank you for joining us. Thank you, Dan, for joining too.
Thank you.
Thank you.
And Dale, do we have to call it? Oh, you're muted.
I think we probably should. Can I get a motion to adjourn?
I'll make that motion.
I can second that. Everyone else is muted.
I gotta pop up in the middle of my screen. Show of hands to adjourn, please. Have a good afternoon, everybody.
Thank
You as well.
Thank you.
Thank you, everyone.